All right, if we're performing a neutralization, we know that the moles of acid and the moles of base are going to be equivalent whenever we get to that neutral point. So the general form is that an acid and a base will give you salt and water. And that's the whole point of things being neutral. You're taking your acid particle, combining it with your base particle, and producing water. So the end result of any acid-base neutralization is water, and then whatever salt was left over from the acid and the base. The math is pretty simple because it's moles of acid equals moles of base, and it uses equations that we've previously done. If it's a solution, our equation for molarity tells us that moles equals molarity times volume in liters. If it's a solid, we get moles by taking your mass, dividing by formula mass. So, this is what's called an acid-base titration. We're going to make moles of acid and moles of base equal. In this flask, I have an unknown acid. I don't know what the molarity is. All I know is that I have 10 milliliters of it. So, I could measure that very accurately, and I'm going to titrate it with a base. The base we're using is sodium hydroxide. I do know the molarity of it very accurately. It's 0.200 molar, and I'm going to measure the volume of it very accurately. So if we measure carefully and do some simple math, we can find out what the concentration of our unknown acid is. I do have an acid-base indicator. This is called phenolphthalein. It's going to let us know whenever our reaction is complete. It will turn a bright pink color in base. And I can tell you it's an acid because it didn't turn bright pink, so we know that this is an acid. We're just going to add our base to the unknown acid until it turns pink and we've reached neutral. And there we are. So that pink color tells us that we're past neutral. This is a base now. And my burette tells me that we have added 18.9 milliliters. So let's take a look at the math. So we can set moles of acid equal to moles of base. Because they're both solutions, we can substitute in ml from our molarity equation. So we have acid side, base side. We're solving for the molarity of our unknown acid. We should know everything else. So, MA, liters of acid. I started with a 10 milliliter sample. This is 0.01 liters. Sig figs. The molarity of our base, according to the bottle, 0.200. And the volume of the base that we used, 18.9 milliliters. So the concentration of our unknown acid is 0.378 molar.